Wow, I sure do love shapes. If only there were cooler shapes.
Did you say cooler shapes?
What?
Introducing fractals, the geometry of everything.
What are fractals?
I'm so glad you asked. In the simplest terms, fractals are a curve or a pattern that includes a smaller curve or pattern which has almost the exact same shape. In other words, fractals repeat themselves within themselves. They look like this.
No way! Those look way more complex than my shapes.
That's because your shapes are Euclidean, or the kind of shapes with nice, straight, regular lines. But nature does not like regular lines, and that's where fractals come in. See, in order to model the natural world, scientists and engineers need to use fractals because, in fact, everything in nature is a fractal.
Including me?
Including you! The trees are fractals, the clouds are fractals, even the structure of your lungs are fractals.
But how do we use fractals?
Great question. Take the coastline paradox. How long is the coastline of Britain? At first it seems simple, just measure the coastline. However, it isn't quite that straightforward. Taking a unit of measuring that is 200 kilometers long results in 2,400 kilometers as the final product. Taking a unit of measuring that is 50 kilometers long comes out to 3,400 kilometers, which is much longer than the previous result. This is because the measure of 50 kilometers was better able to measure all the irregular lumps in Britain's coastline. However, there will never be a definitive point where the units are small enough to measure accurately because the coastline is self-similar. That is, it's infinitely irregular. This makes Britain a closed shape with a finite area and infinite perimeter, which is a property of a fractal.
That's interesting, but how is it useful?
I was just about to explain. See, using this nifty formula here, we can determine the fractal dimension of Britain's coastline.
Fractal dimension?
Yes, fractals have their own dimension. A line has one dimension, length, add width, and you have two dimensions. Fractals exist in between those two dimensions. Going back to the coastline paradox, using the previous estimate for the length of the coastline, the dimension would work out as m equals logarithm of 2,400 divided by 3,400 all over logarithm of 200 divided by 50 is about equal to negative 0.251. One would then take the absolute value of the result and add 1, which results in 1.251 as the fractal dimension of the coastline of Britain. This number essentially measures the squiggliness of the coastline, so you can think of Britain as being 1.25 squiggly.
That's so neat! Fractals are so useful.
They are! Educate yourself on fractals today.